So now we are starting with basic operations involving set theory. So the first one we're talking about union. So when we're talking about union in mathematics under this set particularly means how we can make arrangement of a set in order, that is from the lowest to the highest. That's the meaning of that. For example, let's say we have, and it has a particular notation, set notation, like when we have something like this. When we have something like this, it simply means the union, that is to arrange a set from the lowest then to the highest. For example, let's say we have e.g. if x is equal to 2, 4, 5, 6, and let's say we have y is equal to 0, 1, 3, and 5, and they said find x union y. So meaning we are given x to be 2, 4, 5, 6, and we are given y to be 0, 1, 3, and 5, and we have to find the union set. It means we are to arrange the set x by y. So that means by looking at this set, if you look at this set now, you can see the lower that we have among them is 0. So that means we have is 0, then followed by what? Yeah, so followed by 1, followed by the lowest that we have again, we have 2, followed by 3, followed by 4, followed by 5, followed by 6, and we are done. Just in short, that is, the union set simply means how we can make arrangement of a set that is from the lowest up to the highest. Now, it can be in form of a word problem. You know, in mathematics, we love using the word problem. They can give a word of like, maybe when they give you in terms of words, like they said, this is example 2. If A is equal to all even numbers, or even numbers, let's say even number between 1 and 10, and they said we have B to be equal to prime number between 1 and 10, and the question says find A union B. So if you look at these two sets, we are given the problem in terms of a word problem. For the first one, they said even number between 1 and 10, meaning 1 and 10. You know, let me firstly explain what you mean by even number, because that one is very important. When we have even numbers are those numbers that can be divided by 2 without remainder. Like what? Like we can have 2, 4, 6, 8, 10, and so on like that. These are called the even numbers. We have them like even numbers, we have prime numbers, we have odd numbers, and so on. So if I want to talk about the odd numbers in mathematics, odd numbers simply means the opposite of even number. Like we are going to have that one to be like 1, 3, 5, 7, and 9, for example. So now, but there's a little difference between the prime numbers and odd numbers. When we have prime numbers simply means all those numbers that cannot be divided by any other number except 1 and itself. Like what? Like 2. If you wonder that, why do we indicate 2? Because 2, only 1 can divide 2 and 2 itself. Like 2, like 3, like 5, like 7, 11, 13, 17, and so on like that. So all those ones are called prime numbers. So then I'll go back to that problem. The problem says A is equal to even numbers between 1 and 10. B is equal to prime number between 1 and 10. Meaning we need to firstly identify what is A, at the same time what is B. So A now, if I want to indicate it here, my here will be, they said, even number between 1 and 10. So that means the even number that we are going to have here are 2, 4, 6, 8, and 10. No, because from the problem they say in between, that is in between the 1 and 10. That's why we stop at 8 here. Then from B, they said B is equal to prime numbers between 1 and 10. That is all those prime numbers, that is all those numbers in which they can only divide themselves and 1. Now, from there, we can have that one to be 2, we can have 3, we can have 5, we can have 7. So that means here now we have already simplified our problem. So our A is 2, 4, 6, 8, Our B is 2, 3, 5, and 7. Now let's find our A union B. As I explained, it's just arrangement of a set. Like if I want to find A union B here, so if I look at the set now, the lowest that we have, if you look at A and B, the lowest that we have among them is 2. So followed by 3, followed by 4, followed by 5, followed by 6, followed by 7, followed by 8. So in short, the union set simply means arrangement of a set from the lowest to the high. It can be in form of alphabet. It can be in form of alphabet. It's just that you are going to arrange them from the lowest onto the what? Onto the highest. So let's talk about another set operations. Apart from union, we still have another operations. We call it intersection. We call it intersection. So intersection of a set is denoted by something like n. It's not n, but something like n. So when we are talking about intersection, you know, back to what I explained earlier, I said union simply means arrangement of a set, that is from the lowest to the highest. So when we have the intersection, it simply means what a set have in common. When we look at the set, it can be 3 sets, it can be 4 sets, it can be 5 sets. So we check the set, that what do they have in common? So whatever they have in common is what we call intersection of a set. So meaning they may not be using this word, they will be using something like n to demarcate what you're talking about intersection. Let's look at the example. Let's say I have, if x is equal to ABCD, and let's say we have y to be let's say A, P, Q, and R. And we said that to find x intersection y. Now, if I look at this set, we are given set x to be A, B, C, D. We are given set y to be A, P, Q, and R. So now I want to find their intersection, meaning I want to find what does x and y have in common. So now, if I check the set, from here now, if I check set x, we can see we have element A here, right? So if you look at set y also, we also have A. That means both set x and y have A in common. So I can possibly pick A. Now, let's check another element. If I check B now, we can see we have B here, but do we have B here? No, because we only have set B, we only have element B inside X. So that means if you look at set X and Y, there's no other element in common, which means the only intersection we are going to have as the element is A. So please, it can be any, it can be in form of alphabet, it can be in form of a word problem. I'll bring another example for you to understand more better. Let's look at another one. They said, given that universal set is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's say we have set A to be equal to, let's say we have 0, 1, 3, and 5. Set B, we say we have 4, 5, 6, 7, and we have set C to be 0, 8, 9, and 10. First question, they said find A intersection B. Or let me represent it in a simple way to make it more easier. Find 1 A intersection B. 2 A intersection C. 3 B intersection C. Then 4 A intersection B intersection C. So this is a problem. So here, if you look at this problem, you can see they all depends on the intersections. Now, the first question, they said we have to find A intersection B. You can see here they have indicated the one we are talking about. They are only talking about the set A and set B. That is, what do that two sets have in common? So if I check set A, I have a 0. If I check set B, there's no 0 there, right? In set A, I have 1, there is no 1 here. We have 3 here, there is no 3 here. But we have 5 in set A, and as well as we also have 5 in set B. That means both set A and B have elements in common, which is 5. You can pick out the 5. So you can clearly see, apart from 5, there is no other element again. That means the only thing that they have in common is 5. So let's check the second element. The second question is to find A intersection C, meaning the element that we have in A and also appear in C. If you check set A, we have 0, right? And set C, we also have is 0. That means we can pick out 0. Now, there is 1 here, no 1 here. There is 3, no 3. There is 5, there is no 5 here. So that means the only element that both set A and C have in common is 0. So you're free to go. Now, the third one, they said B intersection C, meaning what we have in set B and we also have it in set C. So when we check B and C, there is 4 here, no 4 here. We have 5. We have 5 here. There is no 5. There is 6 here, no 6. There is 7 here and no element 7 here. So the only thing we can do here, we can see that both B and C, did they have anything in common? No, they don't have anything in common, because when we check B and C, we can clearly see that there's no element in common. So if you watch our previous video, we talk about some types of set. We mentioned what we call empty set. We said empty set is when a set does not have anything in common. So clearly here, this B intersection C is a clear example of a empty set. So that means I can just write this one. That is B intersection C is an empty set, because we check the two and we discover that there is no element in common. And note, you cannot just use two symbols at a time. You see that use empty bracket or use this symbol for empty set. Now, the last questions, we have to talk about A intersection B intersection C, meaning the element that we have in A that also appear in B and also appear in C. So let's check the 3 sets. If we can have something possible like that. When we check A, we have 0 here. There is no 0 here, but there is 0 here. So that means they don't have that one in common. There is 1 here, no 1 here, there is no 1 here. 3 here, there is no 3 here, there is no 3 here. There is 5 here, there is 5 here, but no 5 here. So meaning both A intersection B intersection C is a clear example of empty set, because they don't have anything in common. So that means A intersection B intersection C is also an empty set. So this is a clear example of how we can perform operation on what we call intersection. So we also have another one apart from intersection. There's another one, we have complement of a set. We have complement of a set. Complement of a set. We're talking about the complement. Complement simply means the element that appears in universal but not in that particular set, to be precise. And it has a symbol. To represent that one, they can use something like prime or they use something like C. How? I can write it like this or I can write it like this. So whenever you see these two, it just means the same thing. Either they use A prime or they use AC. The two means the same thing. That is meaning either they use something like prime here. It's not one. It's like a prime. If they use prime or they use C, the two means the same thing. You know, in maths, them two, they used to use some kind of jokes or some kind of symbols that they can use to compare. How would I even put itself? Maybe they're just trying to let you know that we can use a single symbol or more than 2 symbols to represent same thing. Like here now, we are basing on prime and C. Either they use something like this or this, it means the same thing. It means the complement. Complement simply means what we have in the universal set. When we are talking about universal set, it means the parent of all sets, right? So what we have in the universal set, but not in that particular set, is what we call complement. Let's give an example of that. For example, let's say we have, if universal set is equal to, let's say we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And they say, given that set A, let me give you A as an example so that it can be more interesting. Set A is equal, let's say they said even number less than 6. Even number less than 6, they now say find a complement. So that means you can, if you look at set A, it's given in form of a word problem. So I firstly look for what they call even numbers, and I've explained earlier that even numbers are those numbers that can be divided by 2. So even number less than 2 here, we can pick 2, 4, and so since it's a set less than 6, that means 6 will not be included. So that means the only even number that we are going to have here is going to be 2 and 4. Now the question now says to find a complement. That means I want to find the element that we have in the universal set, but not in A. So that means here, if you look at the universal set, we have 0. There is no 0 here, right? We have 1 here. There is no 1 in this set. We have 2. There is no 3. We have 4. There's no 5, 6, 7, 8, 9, and 10. That's what we call complement of a set, meaning what we have in the universal set but not in that particular set is what we call complement of a set. So the main part, or let me just say the most important interesting part in this set is that we can combine all these set operations, either intersection, either the union, either the complement, in a single problem, and it's very easy to solve. Let's look at one example under that. Let's look at a simple example under that. It said, given that the universal set is equal to, let's bring alphabet A, B, C, D, E, F, G, H. And they say given that set X is equal to A, B, D, E, set Y is given as let's say D, E, F, G. Now the first question is find Roman figure 1, X union Y, Roman figure 2, X intersection Y, Roman figure 3, X complement, Roman figure 4, Y complement, Roman figure 5, S complement intersection Y complement, Roman figure 6, X complement intersection Y complement or complement. You can see they're just trying to do some kind of things. You can see all are very simple and straightforward. So far you understand what we have mentioned so far. We mentioned union, that is arrangement of a set from the lowest to the highest. We mentioned intersection, what we have in common, and we mentioned complement, what we have in the universal set but not in that particular set. So let's take them one after the other. The first one, they said X union Y. You know, as I mentioned earlier, union simply means how we can arrange a set from the lowest to the highest. So if you look at the set X, let's look at it. I have A there. The next one we are going to have again, we have B, just like the way we are written ABC. A, B, then we also have D, we have E, we have F, and we have G. You can see that it's very simple and straightforward. Either it's in form of a numbers or either in form of alphabet, you can go with it. Now, the second one is said we should find X intersection Y. That is, what does X and Y have in common? So let's look at set X. In set X, I have A, B, D, E. Let me write this one very well. Then under Y, we have D, E, F, G. So meaning, if you look at set X and Y, they have something in common. Let's check. We have A here, no element A here. B here, there is no B here. But you can see, do we have D? Yes, we have D. D is in X and also in Y. So pick out the first one. E, do we have set E under Y? Yes, there is, because we have E under X and we also have E under Y. So we pick out. So apart from that, there's no other element. That means the value of our X intersection Y is going to be D and E. Now, the next question, they say we should find X complement. You know, complement simply means what appears, the element that is inside the universal set, but not in that particular set. Now, if you check, you have A here, there is A in X. B, there is B in X. C, there is no C in X. I pick out C. We have D, we have E, there is no F, there is no G, and as well as there is no H. Now, if you look at Y complement, that is the element that we have inside the universal set, but not in Y. So if you check, there is A in universal set, but not A in Y. So that means I can pick out A. We have B here, there is no B here. We have C here, there is no C. We have D, yes, there is D in Y, right? So we have D, we have E, we have F, there is G, and there is no H. So that means the value of our Y complement is going to be A, B, C, and H. Now, the next question, they say to find X complement intersection Y complement. Now, we have derived another set apart from X and Y, because If you look at the set, we have a particular set for x complement, we have a particular set for y complement, which means it's quite different from x and y. So that means here now we are going to base our argument on x complement and y complement, right? Because x complement intersection y complement is not the way we are going to find for that of our x intersection y. So now we have another set for x complement, we have a set for y complement. So let's check. It's very simple and straightforward. Let's list the set here to make it easier. What do we get for x complement here now? Our x complement is CFGH, right? So and our y complement, we have it to be A, B, C, and H. Now I want to find x complement intersection y complement. Please don't be confused. Maybe in some materials, I've mentioned earlier, in some materials they can use, instead of writing this in this way, they can write it as a x complement intersection y complement. You don't need to worry about that. It's still the same thing. Either they use prime or they use C. The two are still the same. So now I want to check the element that I have in x complement and also appear in y complement. If you check, we have C here. Of course, there's element C here also. I can pick out C. We have F here. There's no F. We have G here. There's no G. We have H here, and also we also have H here. So which means that the value of our x complement intersection y complement, we have C and H. Now the last question, you can see in the last one, it said x complement intersection y complement of all complement, meaning this is the set that we have for x complement intersection y complement. That is, what element that do we have inside the universal but not in our x complement intersection y complement? That's the meaning of that. You know, we have already got our x complement intersection y complement to the C and H. So do not want to complicate the issue by saying that we should find x complement intersection y on complement. That is, the element that we are going to have that we don't have that we have in this universal but not in our x complement intersection y complement. So let's see how that one goes. So I have x complement intersection y all complement. So this is our x complement intersection y complement. So let's check. We have A here, you know, this is our universal set, right? We have A here. Can we find any A here? There's no A. So let me write this one very well so that so the first one we have A. There is B here, no B here. We have C. We don't have D. There is no E. There is no F. There is no G. But we have H. So that means the value of our x complement intersection y complement of all complement is going to be A, B, D, E, F, and G. We also have another operation like difference of a set. That one means how can we find the difference between two sets? That one is only demarcated with something like minus, like this. Difference of a set. That one too, just like if I have let's say we bring two things. Let's say we have cup and water, and they use something like minus here on that set, to be precise. It's just like what we have inside cup but not in water. So that one is something like that. Or let's bring another one. Let's say I have or let's say we have math. Let's make it more interesting. Set difference. Let's make it more interesting so that we can be able to understand what we are trying to say here. Set difference. Let's say we have mathematics minus physics, meaning what we have in maths, but not in physics. That's just the simple tactics of that. Or let's say physics minus maths. That's just other way around. Now let's bring an example of that. Let's say I have, if x is equal to let's say 1, 2, 3, 4. Let's say we have y to be 6. Let's see, to make it more better, 3, 5, 9, 10. They now say find Roman figure 1 x minus y and y. This is no minus, please. So don't be confused. So you know we have minus in mass. This is no minus. It's just like the element that we have in set x, but not in y. The second one too, meaning the element that we have in Y that is not appearing in X. That's the meaning. It's not as if we are going to minus by saying 3 minus 1. No. That one is not that way. That is the element that we have in set X but not in Y, and vice versa. That's the second one. That is the element that we have in Y but not in X. How? Let's see the first one, X minus Y. You can see, to make it more easier, that's why I'm using the word minus, so that you can be able to understand what I'm trying to say. X, that is the element I have in X but not in Y. So let's check. We have 1 here. Do we have 1 in Y? There's no 1 in Y, so I can pick out 1. We have 2 here. There's no 2 in Y. Of course, there's 3. And at the same time, there's no 4. You can see it's even more simpler to find. Very easy to find, to even understand. It's even understandable. That is X minus Y. It's not minus, so it's not as if you are going to say 1 minus 3, 2. No. That is the element that appear in X but not in Y. Look at, if I want to find the second one now, that is the element we have in Y but not in X. So if I check, if you see inside Y, we have 3, there's 3 here. We have 5, but there's no 5 here. We have 9, there's no 9 in the other one, and there's no 10. So those are the set operation that we have. We mentioned the union, we mentioned the intersections, as well we mentioned the set difference, and as well as we mentioned how to find the complement of a set. So this one can be a single question, so because there's more exercise to come. After this, we talk about Venn diagram.